Hello Year 5 and welcome to today's Digital Technologies lesson. Today we are going to continue our learning about algorithms and explore how algorithms help us solve problems and give instructions to computers. Before we begin, let's think about something we do every day. Have you ever followed a recipe when baking? Or perhaps followed instructions to build something with Lego? Take a moment to think about it. Turn and share to your partner and discuss what you thought. Eva, what did you think? Actually, a shopping list is not an algorithm because it has to be in a specific sequence, and a shopping list is in a random order. What could another example be? Yes, as we said, a recipe has to be an algorithm because you follow simple steps in that exact same order. What would happen if we had put our cake in the oven and then added our eggs? That wouldn't really work, would it? When we follow a recipe or instructions, we are actually all following an algorithm. Now, let's take a look at our learning intention today. To understand what an algorithm is, to identify the key features of an algorithm, to create and test a simple algorithm using Scratch. And by the end of the lesson, you should be able to explain what an algorithm is and use one to solve a problem. All right, guys, what is an algorithm? What exactly is an algorithm? An algorithm is a sequence of instructions used to complete a task or solve a problem. Algorithms are all around us. We use them every day without even realizing it. What could be some examples? Yes, making a sandwich. When Mum made your sandwich this morning, she had to follow some steps. Yes, brushing your teeth can also be an example. When I drove to work this morning, I had to put my Google Maps on. Could that be an algorithm? Absolutely. All of these tasks require instructions to be completed in a specific order. Okay, I'd like you to think of one task you complete every day. Can you think of the steps involved? Let's look at an example. Okay, when we make our bowl of cereal in the morning for breakfast, what are the steps? Yes, Bella. Get a bowl. Beautiful. What's the next step? Pour in our cereal. What's after that? Do we eat it? No. What step are we forgetting? Yes, you add milk. And then we get to eat our cereal. Notice that these steps happen in a particular order. Imagine pouring the milk before even getting the bowl. It wouldn't work very well. All right, there are also 4 important features every algorithm needs. The first is steps. Algorithms must contain instructions. The second is order. The steps must happen in the correct sequence. And the third is a clear start. Every algorithm needs a clear beginning. And finally, an end. The task must finish somewhere. Without these 4 features, something is not really an algorithm.
Now that we know the 4 features of an algorithm, let's see if we can identify some examples and non-examples. As we go through each example, I'd like you to think very carefully about the 4 features. 1. Does it have steps? 2. Are the steps in the correct order? 3. Is there a clear start? 4. Is there a clear end? If the answer is yes to all 4, then we have an algorithm. All right, example 1, getting ready for school. Let's look at our first example. 1, wake up. 2, get dressed. 3, eat breakfast. 4, pack your bag. 5, go to school. Take a moment to think. Would you give this a thumbs up or a thumbs down? This is an algorithm. Can anyone explain why? That's right. It has clear instructions, the steps happen in order, it starts with waking up and ends with arriving at school. Let's dig a little deeper. Imagine we changed the order. What if we packed our bag after arriving at school? Would that make any sense? No, it wouldn't. This shows us that the order of instructions is very important. Even one step out of place can cause a problem. Let's look at example 2, a shopping list. Bread, milk, apples, eggs. Is this an algorithm? This is not an algorithm. A lot of people think it is because it's written as a list. However, it doesn't tell us what to do. It doesn't provide instructions or actions. It simply tells us what items we need. Turn to a partner and explain one reason why a shopping list is not an algorithm. That is excellent thinking. Remember, algorithms must tell us how to complete a task, not just provide information. Let's look at example 3, brushing your teeth. 1. Put toothpaste on your toothbrush. 2. Rinse your mouth. 3. Brush your teeth. Would this work? Not quite. The problem is the order. The steps themselves make sense, but they aren't in the correct sequence. You would normally brush your teeth before rinsing your mouth. When programmers create algorithms, they often ask themselves questions like, does this instruction come before or after this one? Will this still work if I change the order? Have I included every step? These questions help programmers identify mistakes. Let's test one more example. Making a sandwich. 1. Get 2 slices of bread. 2. Add your filling. 3. Put the slices together. 4. Eat your sandwich. Give me a thumbs up or thumbs down. Thumbs up. That is an algorithm because it has all 4 features. Now, what if we change the algorithm? 1. Eat your sandwich. 2. Get 2 slices of bread. 3. Add filling. 4. Put the slices together. Would this work? Definitely not. You can't eat a sandwich before you've even made it. This might seem funny, but computers work exactly like this. They simply follow the instructions exactly as they are written. This is why algorithms are so important in digital technologies. When we start coding in Scratch, the computer won't guess what we mean. It only follows the instructions we give it. If our instructions are out of order, our program won't work correctly. In our next activity, we're going to see this happen when we create and test our own algorithms in Scratch.
Now that we've identified what an algorithm is and what makes a good algorithm, we're going to create our own digital algorithm using Scratch. Scratch is a visual programming tool that allows us to create algorithms by connecting coding blocks together. Instead of typing coding, we drag and drop blocks to tell the computer what to do. Remember, computers cannot think for themselves. They only follow the instructions we give them. This means our algorithm must be really clear, accurate, and in the correct order. Alright, let's start by looking at some coding blocks we will use today. The first block is the green flag block. The green flag block tells Scratch when to start running the algorithm. Without a start block, our algorithm won't know when to begin. Next, we have our move block. This tells our sprite how many steps to move. Finally, we have an end block, which tells the program when the algorithm is finished. Notice how these blocks help us create the same features we discussed earlier: a start,
steps, correct order, and an end. Let's build our algorithm together. First, I'll drag the green flag block into the workspace. Next, I'll add a move 50-step block. Then, I'll add a turn 90 degrees block. Let's read our algorithm from start to finish. When the green flag is clicked, the sprite will move 50 steps and then turn 90 degrees. Before we test our algorithm, I want you to think like a programmer. Take a moment and make a prediction. What do you think will happen when I click the green flag? Will the sprite move first? Will it turn first? Will it stay where it is? Turn to your partner and have a chat about it. Let's find out. I'm going to click the green flag. We can see that the sprite moved forward and then turned. Our algorithm worked because the instructions were clear and in the correct sequence. Testing is an important part of creating algorithms because it helps us check whether our instructions are producing the results we expected. Alright, now let's investigate what will happen when we change the order of the instructions. I'm going to swap the two blocks. Instead of moving first and then turning, the sprite will turn first and then move. Before we test it, I'd like you to make another prediction. Do you think the sprite will end up in the same place? Why or why not? Let's test it. Did you notice what happened? The sprite ended up in a completely different position. Even though we used the same blocks, changing the order changed the outcome. This demonstrates one of the most important ideas in digital technology. Sequence matters. Algorithms only work correctly when instructions are organized in the right order. Sometimes when programmers test their algorithms, they discover that something doesn't work the way they expected. When this happens, they look for mistakes and make improvements. This process is called debugging. Debugging is not about getting everything perfect the first time. It's about testing, learning from mistakes, and improving your work. In fact, professional programmers spend a lot of time debugging their programs. Alrighty guys, so today we successfully identified coding blocks, created a simple algorithm, tested our algorithm, we changed our sequence, and we observed how the outcomes changed. This helped us understand why algorithms must be tested and improved.
Okay, so before we finish today, we're just going to answer these 3 questions. What is an algorithm?
An algorithm is a set of clear instructions or steps that tells a computer or person how to complete a task or a problem.
Yeah.
And it can't be in a random order.
Awesome. Now, name one feature of an algorithm.
One feature of an algorithm is that the steps must be in the correct order or sequence so the task can be completed successfully.
Great, I love that you remembered that. And your last question, what change did you make when testing your Scratch algorithm?
When I tested my Scratch algorithm, I noticed something that did not work correctly, so I changed the order of my blocks to make sure my character moved and completed the task correctly.
That's so great to hear. Well, thank you for learning with us today.